Hi there, this is Mr. Bainey. This lesson is 3.1, Representing Proportional Relationships. The standard up on the top right is 8.EE.6, and our essential question is, how can you use tables, graphs, and equations to represent proportional situations? So the key word here being proportional. Let's make sense of what this word right here means. So the explore activity, let's go through it. In 1870, the French writer Jules Verne published 20,000 Leagues Under the Sea, one of the most popular science fiction novels ever written. One definition of a league is a unit of measure equaling 3 miles. So this means that 1 league is the same as 3 miles. Just like 12 inches is the same as 1 foot, right? We're just using different units there. So let's complete this table. So we see that the 1 league right here is equal to 3 miles. Okay, the first row is leagues and the second row is miles. So let's fill in the rest of this table. So 2 leagues is going to be the same as 6 miles. 6 leagues is the same as 18 miles. If I know the number of miles, I can just do the reverse, right? Go backwards. And 36 miles will be 12 leagues. 20,000 leagues is going to be the same as 60,000 miles. So as you're following along, were you able to figure those out before I wrote them down? Because that's going to be important in understanding how these proportional relationships work. So what relationship do you see among the numbers in the table? I'll let you think about B and write something and think for yourself what you notice. So think about, what do you notice? What relationships or what patterns do you see with the numbers in the table? Part C, for each column of the table, find the ratio of the distance in miles to the distance in leagues. So this means that 3 miles is the same as 1 league, so they're putting this as a ratio. So 3 miles over 1 league, 3 divided by 1 is 3. Okay, 6 miles is the same as 2 leagues, so 6 divided by 2 is 3. 18 miles is the same as 6 leagues. 18 divided by 6 is 3. Then we have 36 miles is the same as 12 leagues. We divide, we get 3. And then lastly, we got 60,000 miles divided by 20,000 leagues is also 3. So we're doing the ratio of miles to leagues. And what are we getting every single time? We're getting this number that's right here. So what do we notice? We notice it's always equal to 3. In fact, we call this a constant ratio. Constant ratio of 3. Okay, you're gonna see that terminology a lot more than just saying it's always 3. The ratio is constantly going to be 3 in this. We can add more to this table as well, but what ratio are we always going to get? We're always going to get 3. Okay, there's some vocab words on this next page, and I'm gonna add just a little bit more to it. We have a proportional relationship is the relationship between 2 quantities in which the ratio of one quantity to the other quantity is constant. So really, the gist here is, for a proportional relationship, we have a constant ratio. Every time we divide, if we get that same number every single time, we will it will be a proportional relationship. And so the constant of proportionality is this k right here. It is equal to this constant ratio, whatever that is. We're going to write the equation like y equals kx, and we might be able to use this second thing that I boxed, k equals y over x, to help us figure out what that k is, right? K is the constant of proportionality. So our y equals kx just means that our equation will always look like y equals something times x. And that something is the constant ratio, or the constant of proportionality. Okay, so let's take a look at the your turn down here. 15 bicycles are produced each hour at the Speedy Bike Works. Show that the relationship between the number of bikes produced and the number of hours is a proportional relationship, and then we're going to write the equation for the relationship. So we have to do two things here. We have to first, we have to first show that the relationship, or show that the relationship is a proportional relationship. That's the first thing. The second thing is we're going to write an equation. So we have 15 bicycles are produced each hour. So I'm going to put how many bikes are produced in how many hours. So 15 bikes in 1 hour. So 15 divided by 1 is 15. So let's add an extra hour to that. How many bikes will be produced? It'll be 30 bikes, and that'll take 2 hours. 30 divided by 2 is 15. If I add an extra hour to that, I'm going to get 45 bikes total. That'll take 3 hours total. And when I divide that, I get 15. So as I go through this situation, doing three ratios is plenty to make sure that it's constant. And so you're going to see that every single time I divide, I'm going to get 15. This is like my check to make sure I have a constant ratio. And that constant ratio is going to help me write my equation. My equation, remember, is going to look like y equals something times x. And that something is the constant ratio. And so that ends up being 15. And there's my equation. On the next page, we'll be able to also look at making these equations, looking at proportional relationships really on a graph. So we're going to show that the relationship between, or we're not going to show, but this graph shows the relationship between time that a backpacker hikes and then the distance that he travels or she travels. So the 0.5 comma 6 is this point right here. This is 5 comma 6. What does it represent? So if 5 is my x, so 5 is going to be our time in hours, and then the 6 is going to be the distance in miles, because that's my y. So I have 5 hours to go 6 miles. Okay, and so without me telling the answers, be able to also describe what the other points would represent. So things like this next point right here would be the point 10 comma 12. So what does 10 comma 12 represent? Right, in hours and miles. And also, what does this one, this is 15 comma 18, what does that represent? Okay. So now that I have these points, it's a good idea to know how to identify those points that I've written down on the right side, because now we can write our equation. We want to get our constant ratio, right? We want to do the y. Right, remember that k is equal to y over x? Okay, that was on the previous page. The y is miles, and the x is hours. So this means 6 miles would take 5 hours. I would suggest using something like a calculator for this, just to make this a little bit easier, but you're going to get something like 1.2, or you will get 1.2. Our next one is it's going to go 12 miles would take 10 hours. And if you divide that, you get 1.2. And then lastly, to go 18 miles, it'll take 15 hours. All right, I'm getting all of these numbers from the points, by the way, if you're not sure. And then when I divide 18 by 15, I'm going to get 1.2 again. So here, check it out, constant ratio, right? So my equation, y equals something times x, that something is the constant ratio, 1.2, and I'm done. I will also accept all of these fractions or ratios, these things that I'm making, not making, but that I'm putting together, all reduce to 6.5. They all reduce to this, right? Because if you divide both of those by 2, you get 6 over 5. So I will also accept y equals 6 over 5x. So that is the same thing, right? Because 6 over 5 is the same thing as 1.2. Either one would be fine. I might prefer the fraction instead of the decimal, but either one works just fine. Okay, and that's going to be it for this lesson. Fairly short. We'll continue to work with proportional relationships throughout this module. Thank you so much for watching. Hope it helped. Have a great day.